Hello again. Let's go over solutions to the assignments out of section 6.1. So the first problem is we want to convert an angle from degrees into radians. So the only thing to really remember about these conversions between radians and degrees is that going all the way around the circle is 360 degrees or 2 pi radians. In terms of units, if you're working with degrees, make sure to use the degree symbol. If there's no symbol attached to there, everyone is going to assume you mean radians. So this just means that if I want to convert 385 degrees into radians, I just need to remember that there are 2 pi radians per 360 degrees. This is typically simplified to multiply by pi over 180. So this is 385 pi over 180. The degree unit cancels out. If you want to simplify this down further, you absolutely can. So let's see, I can definitely cancel a common factor of 5. So 385 is 5 times, I've got a 1 and a, that'd be 350, I need another 35, 77, and 180 is 5 times 36. So if I cancel that out, we have 77 pi over 36. Okay, moving on. Another angle that we want to convert from radians to degrees. So once again, we just need to multiply by pi and divide by 180 degrees. The degree unit cancels out, giving us 195 pi over 180. There's again a common factor of 5 that we can cancel out. This will leave us with 39 over 36, again, times pi. I can actually cancel a 3 out as well here to get 13 pi over 12. Next up. Convert an angle from degrees to radians. Well, this is pretty straightforward. Okay, by now we know we multiply by pi, we divide by 180 degrees. The degree sign cancels out, so we have negative 90 pi over 180. This is now measured in radians. 90 over 180 cancels to 1 over 2, so we have negative 1 pi over 2. And again, with no unit symbol on there, it is understood that this is in radians. One more, convert degrees to radians. So negative 60 degrees times pi radians out of 180 degrees. 60 goes into 183 times, and we have negative pi over 3. As you get comfortable doing this and you practice more, you'll recognize certain angles that you just, in essence, you end up memorizing them just by having worked with them so often. 30 degrees is pi over 6, 45 degrees is pi over 4, 60 degrees is pi over 3, and 90 degrees is pi over 2. These will all just become second nature to you. And now we just have to go the other way. We're going to convert from radians into degrees. So if I have negative 7 pi over 6 radians, and I know that there are 360 degrees out of every 2 pi radians, this is just one complete circle. This would typically be written as 180 degrees over pi, okay, by canceling out that common factor of 2. Going from degrees to radians was multiplying by pi over 180. So to go the other way, from radians to degrees, we multiply by 180 degrees over pi radians. These pi's will cancel out. 6 goes into 180 30 times, so we have negative 210 degrees. Another problem of converting radians into degrees, well, pi over 30 radians times 180 over pi. Pi's cancel, degrees, sorry, and then 30 into 180 leaves behind 60 degrees. This is one of these, 6 degrees. This is one of these angles that you just sort of recognize that pi over 3 is 60 degrees, and this is just 1/10 of that. All right, convert from radians to degrees. Well, negative 7 pi over 6 times 180 over pi. Pi cancels pi. This is 180 degrees. I apologize. 6 into 180 leaves behind 30, negative 210 degrees. This looks awfully familiar. I'm pretty sure it was a problem we already had.